Cool. All right. Good afternoon, everyone. I hope you are enjoying the event. And thanks a lot for coming today in our observability chat. I'll be chatting a bit about Delivery Hero. My name is Vinicio. I work in Delivery Hero. We're based in Berlin. If you don't know what it is, we are a food delivery company with a very particular strategy on how to approach that. I'll make a comparison. If you look at Uber Eats, when Uber Eats buy a new market, what they do is they try to put their own identity in the market, right? So they will get their own app and they'll put a journey on that app. Delivery Hero believes in a different approach, which is to maintain the local brand, the local strategy, and kind of as an appeal for that specific subpopulation, right? So those are the ones that we have under the umbrella today, the Delivery Hero umbrella. Can I get a quick show of hands if you ever used any of those apps here? Oh, cool. Yeah, they're better than Deliveroo, no? We also have a called number first strategy. So every single market that Delivery Hero is operating is fighting to be the first. And if one day we believe that it's not possible to be the first, then the market is exited. So basically that's the overall strategy. And I think this is the most important point I wanted to connect with this presentation today, which is around data quality. Is because we sell software, right? We sell a logistics algorithm on how to connect the couriers into the users. And you can only make money if you are operationally excellent. And the only way to be operationally excellent is that if things run well. So to have data quality is not a matter of choice. Like the only way the Delivery Hero can succeed is that if we have a strong data backbone that can feed into those verticals of logistics, of vendor, and so on. Now let's go a bit into data. So we have a lot of diversity of brands and therefore diversity of team of people. And today, the way that we chose to support it is with our product called Data Hub. It's based on data mesh, and every single team gets their own DDU called a data domain unit. It's a box where they are end-to-end accountable for anything that happens to the data product. We spin up more than 500 Airflow instances, and we have about more than 12 million monthly executed tasks. So we get all this data, we orchestrated it, and we dump into a warehouse in BigQuery, where more than 42K monthly active users, they're going to query that data directly. Directly means you write SQL in BigQuery, or you have one service encapsulating your credentials. I think those would also apply. We have another layer of users, which is we call the indirect business analyst, right? So there are people that are consuming only from dashboards, or people that are querying directly. Up to those, if we sum those together, we have about 12K users worldwide. So everyone consuming the data. Just give a bit more context about how the product is structured. Is first we have our infra. Let me test if this works. Nice, it doesn't work there. We maintain 100% of that. It's running on Airflow. You also get an out-of-the-box cost optimization, performance, observability, cost observability. On top of that, we have our own application. I think one core principle of our application is contribution, right? We have 70 countries, so there's a lot of engineers, a lot of opinionated people that are good technically, and if they can contribute well to the product, why shouldn't we let them? No? So this is what we try to do. Today, 30% of all of our contributions to the core, which means as a DDU, you make a contribution to the application that can be reused by any other DDU. It's about 30%. There's a few ways to contribute using our native curated framework, using one SDK, a Python SDK, or even dbt. There's also available. All to get to the red box, which is a data product. The red box is basically the end goal that we want to achieve, which is we want users to be empowered to own their products. No? And I'll be talking a bit about data contracts in a bit. And finally, we have a data consumption layer with a data catalog, with data access flows, where all the data gets into BigQuery and users can consume it from there. Okay, now I'll be doing a drill down in a specific use case, which is demand forecasting for vendors. And then you might ask, but why? It's one of the pillars that we have in DH, right? I think it's the core one. First, let's assume that we are really successful in doing demand forecasting. What do we get? First is courier allocation, which is the largest pool of money that we have to use. Then courier, we spend less time waiting. We maximize the rotation that they do. Also, we can minimize the food being hauled into the restaurant itself. There's a secondary goal, which is you can also provide this data to your vendor. I think we have a few initiatives like this already. It helps them manage their own inventory or manage their own people or have at least some estimate of how their customer is supposed to consume them. So I have dramatically oversimplified our model for demand forecasting over data ingestion, feature generation, and modeling. I think especially feature generation depends a lot of how mature MLOps pipeline is. Let's assume that it doesn't matter, right? If you use the feature store or if you're computing everything by yourself, let's assume those variables don't matter. And here is where we're using Monte Carlo. No? I'll be doing this is more like the what, and then we're also going to do a drill down on how we're engineering this. But we basically apply two types of checks. One check is called the off-the-shelf check. You can get frequency and volumetry, which means if you expect data to arrive every day, or if you expect an increment in a data attribute every day and it's not there, then it triggers a flag. Or you can write your own checks. No? One example, just looking at the amount of valid vendors over a new increment of data, that would be a good alert, a good check. And what we want to do is, when we're going to this curve of optimizing for a model, we want to make sure that we are able to get the issues as early as possible. No? So the more efficient we are in identifying ingestion and then the feature generation, the better is the quality. Because every time I go from one step to the other, and of course we oversimplified into only 3 steps, but every step that we go through, it makes the identification way more expensive. No? Because if I know that I have extreme drift in the ingested value, or the event didn't come, then of course, when I compute the feature is going to look weird, no? So we already know that. A second event that we can see of this would be for another model. If you have another model, even if the feature generation step is slightly different, in the end, you have the same events going from ingestion. So as soon as you're able to get at the event level, at ingestion level, what is wrong, you can prevent the propagation downstream, right? So the ecosystem we'll be showing now is basically to achieve this purpose. We want to move the bar as far up to the left as possible. No? Yeah, it looks like this, basically. No, we have we're going to have at monitor level. You can see there is a custom SQL, and then this executes recurrently. It depends on you how recurrently that is, or on your service. And basically, there's 2 parts. One code part, we're going to see in a minute, and the metadata part. And the way that we implement the metadata part is with data contracts. So a data contract is just like a regular contract, no? If you have a contract with your landlord that says you cannot feed pigeons in your building, it's very common in Germany, all contracts have that. Must have a reason, yeah? Then you feed a pigeon, your landlord can legally evict you, no? That's how a contract works. If you have a data contract and you establish a given alert or a given SLO and you don't meet that particular SLO, you're breaking the contract. You're being illegal. No? So that's the premise of the contract. A few important pillars of this is, first is tiering. which basically is the level of importance of your table. We go from 1 to 4, 1 being the highest. Ownership, usually team, but if it's a low one, you can also have a person, that's okay. Metadata definition. And I think this third one is quite important because historically, in data engineering, what we always have done is you have your own pipeline, and as we became YAML engineers, you have your metadata definition as 2 isolated blobs, no? But I think in the future, probably what's going to happen is we no longer have metadata definitions. You only have the data contract. And the data contract is the artifact that describes the metadata of the data product. No? So this is what we're trying to row in this direction. Data tagging, PII, personal sensitivity or business sensitivity. And of course, we have the quality checks. So as I said before, the quality checks, just like we have the analogy of the regular contract where you can put the definition of the house, like how many square meters does it have, how many rooms, right? You have this block, and then the agreement in between the landlord and the rentee. And it's the same, right? So we want metadata definition, but we want also to agree on a minimum set of rules and checks that we have in between the producer and the consumer. Yeah. Today, the way that we measure all of this is when a contract becomes inactive, we count the time in which the contract is inactive. So let's say you have a check and the check broke, and the time that you get to fix that particular check is inactive. It's a downtime. No? So one mechanism that we have to incentivize the data owner is you can guarantee a certain volume of uptime according to the data product. You know? So that's what we're trying to achieve. Okay. So we implemented data contracts through our own SDK. Okay, this looks well. So we have our block of metadata definition at the top. Then we have metadata description. We have producer and consumers. But it's very descriptive. I mean, it's not meant to be anything very, very complex. And then you have the quality checks, no? So one thing that you can do is you can also have different quality checks for different customers. Let's say you have a big table and you want to store all of your orders there, and you want to agree that a particular subset of your customers need one check. Maybe they need to check on one data attribute and others need to check on another data attribute. So you can also do that. You have the flexibility to filter out by the subpopulation of your consumers. Okay. One important thing, because of our implementation, running on top of Monte Carlo, which I'll also give a kind of a high-level overview in a bit. There's 2 ways to deploy the checks. One we call the Monte Carlo checks, is one structure, really easy to use, no? In my opinion, the more standards you have, the better it is, because it leaves less room for error. Or you can also run great expectations, or you can also run your own custom SQL checks, and those would also run on top of Monte Carlo. So you have the flexibility as a user to decide. No, you have all the examples, and you can decide what you think will be the best option. Okay, so our data consoles, as I said, are created by the SDK. How does this work? We have this SDK right here, and then it's called independently to our declarative data hub SDK, right, which is the one that we use to create the data products. We don't actually have a UI, but I put it there because it's our vision, right? We aim to consolidate most of data production to a UI. But the same applies, right? As you can see, it propagates. It doesn't matter where you're doing data production. If you're doing in your ML notebooks, if you're doing the UI, if you're doing VS SDK, no. What it matters is that you're calling in the SDK, and then you're calling in the data contracts SDK, no? So that's a way to always guarantee scalability. That it doesn't matter what we do down the line from the right, we can still call and we can change interdependently. So if you want to add new definitions and to add new governance, change the rules, it's super easy to do. Why is this important? We have 70 countries. Every single country has a different data law. No? So it might make sense that one metadata definition from one data product in Turkey has a different setup than from another one in Taiwan, right? It's just, and we need a framework that's flexible enough. So if we need to change this type of metadata and incorporate, it can propagate downstream. No? Also, more of a personal choice for us, I think, which is always using monitoring as code whenever possible. So, especially if you're using Monte Carlo, you can apply checks via the UI. Personally, I think via code is always going to be better, no? Because you have to guarantee scalability. That's one thing that we established, and also a source of truth. Any engineer, any person in the company, they can go to the repo and they can check the code, no? So there's no doubt that the code in the repo is applying a particular check because it's there. It requires no maintenance, and also replicability. If you need to copy something, if you're creating a new dependency downstream and you want to reuse that frame of the data contract with the same checks, that's possible. Okay, so I know everyone is talking about AI agents. They really like this in this conference, so I wanted to put a bit. Where do you put them? So in my opinion, first, I really like the sentence, all things are important, but some things are more important than others. Yeah? So you don't have to apply monitoring to everything. Maybe you shouldn't even have data for everything, but I guess it's a different discussion. No? But I think there's a lot of room for improvement in auto-tagging things, especially just look upstream. If you're inheriting a potential PII attribute, then it should be flagged. So that's a PII or not, right? Another thing is tracking incident management or errors, or automating and see if, or doing like incident troubleshooting. I think there's also potential. But the point is, when it comes to the data contract, I always want one person, one human, one team to be accountable for it, right? Because it's their contract. And if something breaks, we should be able to go there and talk it out. Yeah. Cool. Just a quick recap then. We have a bunch of data in Delivery Hero, and we need a way to guarantee end-to-end data quality. So what we try to do is to create a flexible code base that will get all those requirements from 70 or so countries and propagate downstream to all of our data products. I think tiering is the most reliable mechanism that we have to do that because it allows us to segregate the data according to the need. We decided to do this by automating our data contracts via one SDK, which is a plugin, and we can propagate this plugin by integrating to the many ways that we have to produce data. And finally, we chose to work with Monte Carlo to automate those quality checks. Now, you notice that I didn't particularly put the UI of Monte Carlo here, but then you can go to their booth. Yeah, they're going to show you this step by step of what go there. You can also use the secret code to get a hat. Okay. And I'll take some questions, please, or comments if you have it. Yes, please. Can you get him a mic? Thank you.
Thank you very much for the presentation.
Sure.
Could you used on one of your last slides the word govern there.
Sorry.
Can you not hear me very well?
Oh, now I can. Sorry.
I'll just yell. Is that okay?
Yeah.
You used the word govern on one of your last slides. In your view, could you share the difference between observability and governance, or whether they're one and the same, or just differentiate between them?
Good question. I think I would get governance closer to the law, no, to the definition of GDPR, for instance. And then there's a set of things that we have to do to achieve that. And observability, I think, is more the technical implementation of how you can track that data. No? I think our observability goes in Monte Carlo, and our governance goes into the data contract, which is the metadata definition and those guardrails. No? So, yeah. Thank you.
Anyone?
Then thank you very much.